Welcome you all. In this session, we are going to discuss in detail about the construction details of DC machine. So, we are thorough with the construction details. You might have studied it in machines one. Even though it is without a thorough knowledge in construction details of DC machine, we can't go for designing the parameters. Right. So first, let us recollect the things of construction details. So a DC machine is used for industrial electric drives have three major parts. They are field system, armature and commutator. These are the three major parts of a DC machine. Let me repeat it again. Three major parts are the field, armature and commutator. The field is located on the stationary part of the machine, which we call it as stator, and it consists of main pole, interpoles, a frame or yoke. So these parts come under the stator, or we call them as the field system. The armature is the rotating part of DC machine, and it consists of armature core, slots, armature winding. These things comes under the rotor. Armature comes under the rotating part or the rotor. So the third thing is the commutator is mounted on the rotor of DC machine. So the commutator and brush arrangements work like mechanical dual converter. So it's work like a converter. So we are going to discuss in detail all these things. So the construction of DC machine can done by using some of the essential parts like yoke, pole core and pole shoes, pole coil and field coil, armature core and armature winding, otherwise conductor. Armature windings are otherwise called as the conductor, commutator, brushes and bearings. Some of the parts of DC machine are listed below. See, the outermost covering or the frame, we call them as yoke. Then the stator. So immediate next to the yoke we have the stator winding and the field poles. Followed by we have the armature conductors. Then the innermost, then again nearer to armature conductor we have the commutator. The centermost part we have the shaft. So it goes on like that. So now let us discuss one by one. So the first part is yoke. Another name of yoke is the outer frame. The main function of yoke in the machine is to offer mechanical support intended for poles and protects the entire machine from moisture, dust, etc. The materials used for yoke are designed with cast iron, cast steel, otherwise called as a rolled steel. So these are the materials commonly used for designing yoke. Pole sign pole core. The pole of DC machine is the electromagnet and field winding is the winding among the pole. Whenever field winding is energized, then the pole gives the magnetic flux. The material used for the cast steel, cast iron and otherwise pole core. It can be built with the steel, annealed steel limitations for reducing the powder drop because of eddy currents. Pole shoe. Pole shoe is in DC machine is an expensive part as well as enlarge the region of pole. So usually the main function of pole shoe is to distribute the magnetic flux uniformly. So in order to get a uniform magnetic flux, we go for pole shoes. Because of this region, the flux can be spread within the air gap as well as the extra flux can be passed through the air gap space toward armature. The material used to build the pole shoe is cast iron, otherwise cast steel, and also used the annealed steel, the limitation to reduce loss of power because of eddy currents. So the next part is field winding. In this, the windings are wounded in region of pole core and named as field coil. Whenever the current is supplied through the field winding, then it electromagnets the poles which generates the required flux. The material used for the winding is copper. Armature core. The armature core includes a huge number of slots with its edges. Armature conductor is located in these slots. It provides the low reluctance path toward the flux generated with field winding. The materials used in this core are permanently low reluctance materials like iron, otherwise cast iron. The limitation is used to decrease the loss because of eddy current. Armature winding. The armature winding can be formed by interconnecting the armature conductors. Whenever an armature winding is turned with the help of prime mover, then the voltage as well as magnetic flux gets induced within it. This winding is aligned to the exterior circuit. The material used for this winding are conducting materials like copper. Commutator. The main function of commutator in DC machine is to collect the current from armature conductor as well as supply the current to the load using brushes. So it collects the current from armature winding and it provides it to the load, and also provides unidirectional torque for DC motor. So the main function of commutator is to collect the current from armature conductor as well as supply the current to the load using brushes, and also provides unidirectional torque for DC motor. The commutator can be built with huge number of segments in the edge form of hard drawn copper. The segments of commutator are protected from thin mica layer. Brushes. Brushes in DC machine gather the current from commutator and supply it to the exterior load. Brushes wear with time to inspect frequently. The material used for brushes are graphite, otherwise carbon, which is a rectangular form. The size of DC machine depends on main or the leading dimension. So now comes the conclusion. So the size, if you go compare the size of machine, it mainly depends on the leading dimension, or we call it as the main dimension of machine. The diameter of armature, which is represented by capital D, and the armature core length L, capital L. So the main parameters D and L. So the size depends on the diameter of armature D and the length of armature core L. As the output increases, the main dimension also increases. If the rated output increases, the main dimension D and L increases, thereby the size increases. That is what they mean. So that's all about the construction details of DC machine with respect to design. Thank you.